A lot of the research around the total knee replacement has been looking into 4 different main areas. One area has been tribological aspects, so wear and friction. Another area has been the mechanical performance of the components, whether it's likely to deform or to break within the body. Another area has been looking at the fixation, and then a final aspect has been how it can be imaged within the body. When we look at things like wear, we tend to be placing the components into mechanical simulators and measuring the amount of wear that's produced during a walking cycle for the equivalent of 10 years worth of typical use. When we look at the mechanical aspects, we would perhaps look at the typical amount of load that is taken by the component during a cycle and replicate that over a number of iterations. With the fixation, often we're looking at what's happening during surgery. The component is typically held in with acrylic bone cement, and we will simulate that surgery either on cadaveric specimens or on polymer sawbones, and then we'll look at what the end component or construct is like, so the full assembly. And then when we're looking at imaging, we'll quite often take the components to a cadaveric lab and implant and take them to hospital scanners and look at the full gamut of potential modalities, so MRI, CT, X-ray, and we're looking for both can the component be seen, but also what can we see around the component, so that the typical structures of the anatomy.